everyone, now we let's start to the next part for the menu calculation. We had to send to Mr. Hiyang for the report, and we will display and calculate by structure expert. Now we have to comparison 3 design code. I will scroll down and tell you basically about this touch. You can read it detail by yourself. I just tell you briefly about what this test talk about. Okay, you see here we will calculate based on the ACI code, based on the Eurocode, based on the Singapore code. Singapore code is similar code with the BA8110. It is very similar. Okay, it's the same. Now we have to check about the design code. We have for the ACI can classify it as ROSDs, okay, resistant vector design, and ASD for the low post rate design. And you see here about the code type or design. Okay, ACI can design on 2 types, okay, ROSD, OSD or ASD. For the Eurocode based on limited design, and for the CP4 low post rate design. Okay, now let me compare. This is for calculating soil bearing capacity, but we do not focus about this. We want to focus about how to calculate 3 bar in concrete pipe. Now let's skip this part. You can read it. You see here about the safety factor for different code. Okay, for the thrust, for the friction, and for the unbearing, it's different. Okay, different of this code. You can read everything from here. Okay, now for the structural design, you see about summarize different column in ball pie. Okay, in the ball pie we have a problem about quality control, or to make sure about concrete strength is strong as column. It's not the same column. Column is the superstructure, no effect from water, from mud, or from other material in the ground. But ball pie you have other consideration for calculation and ratio of the strength in the concrete. So you have to make sure how to select your concrete strength to design. It is limit on the Singapore code how to use concrete strength, but for the ACI and the European not limit upper value for the concrete strength, only for the Singapore code that limit this concrete strength. Okay, the summary. These are summary formula for the ACI code. You can check here more detail about how to calculate, and everything we will show you briefly at the end of this section. At the end of this set, I will include it, calculating it automatically by using summary specific. You can see here about the bearing capacity of the cross section of the column, and for the calculating we have to consider about the strength reduction factor based on the column spiral or tie column. It is ACI code, and another one for the reduction factor for the eccentricity is here. And you see here everything that we combine each other based on the cubic strength, concrete cubic strength SCU. You see here 0.35 SCU multiply cross section of the concrete ball pie. And this is a working load of the concrete ball pie is here. You can check by divide the safety factor 1.4. 1.4 is come from 1.2 for the load and multiply with 1.6 for the load and divide it by 2, you will got the value. It is pretty similar with BS and European, you will got the same value 1.4. okay, you can check here, divide by 2, okay, 1.4. So after you divide the value by 1.4, you will receive the working load. Okay, working load, that because they are only for the concrete section, not include rebar for the formula. And you will see here for the IBC low post stress is 0.26 SCU, and this one is 0.25 SCU AC. And for the Singapore code practice for the foundation, you see here the formula for calculating column, and this one we calculate it based on our structure with no consider about eccentricity, but to reduce this we can issue for the cross section that is with eccentricity, and for receive of the concrete only, not include rebar. So it's the same with the ACI code previously. The formula for calculating the cross section, that we take only concrete strength, not include the rebar strength. Okay, now you see here it is the same with the ACI code about the allowable or working stress is 0.25 SU. It's the same, and you see here, but for the CP4 Singapore code is limit the concrete stress working stress to 7.5 megapascal. That it concrete allowable stress is equivalent with 50, okay, 50 megapascal. So for the Singapore limit for the concrete strength in ball pipe is 30, okay, 30 megapascal. You see here 30 megapascal, which means that allowable stress is equal around here. Okay, because the issue associated with ball pipe construction, okay, before the quality of concrete during construction. So this code limit the concrete for the ball pipe only 30, okay, 30 megapascal. And for the Eurocode and ACI code, no upper limit for the value you can use, but you have to consider about quality by drill in the ball pipe and to compare it actually. We will got the actual result to make our structure SAS CP4 limit the value. Okay, the value for good practice. Okay, for good practice. Okay, the value. So for the ACI and Eurocode, no limit about this. You see here about Eurocode 2, we focus about concrete only, not include rebar. So you will know why we not include rebar in ball pipe. You see here it is very similar for the working stress, but for the Eurocode is 0.29 SU. For the ACI is 0.25 SU, and for the Singapore code is the same, but for the Eurocode you will got the higher working stress. You see here everything about the code about articulation. I write it visually. I write it comprehensively based on a code. You can check it. And this is a construction torrent. In conclusion, okay, for the allowable concrete stress, megapascal for the ACI is 0.25 SU. SU cubic strength based on the BA code. Cubic strength. Cubic concrete strength, not cylinder strength. Okay, and for the Eurocode is 0.26 SU. Okay, after we reduce from 0.29 SU to 0.26 SU, and for the CP4, you see here 0.25 SU. So to conclude about concrete strength is about SCU divided by 4. Okay, example is I has a concrete strength for the concrete ball pipe for 30 megapascal. After divide by 4, you will got allowable strength of the concrete is 7.5. is the limit for CP4 for the Singapore code. Okay, so you can take higher concrete strength, higher than 30 to 40 to 50, but you have to make sure your concrete strength is it has verified by drilling, and you get you take it to laboratory to test the concrete strength, and you got the actual strength of the concrete in your ball pipe, not based on your concrete you buy from the budget from the plant. Okay, concrete budget plant, because the strength is not actual strength in the concrete ball pipe. You have to make sure everything is verified by the laboratory or actual concrete ball pipe. Okay, now you can check for the difference about this touch in these references. Okay, this is the minimum rebar area for longitudinal of the ball pipe. It is the cross section of the ball pipe. You see here the summary. You have to check your ball pipe has the minimum concrete rebar in concrete. But for the ACI code, limit ACI code limit minimum 1% of the rebar for column. So you can check more detail about ACI code about limit of the rebar in the concrete. If you design it based on the ACI code, and you have to follow the code to make sure everything is compiled with the code. Okay, but for this video is for the Eurocode. Now we have to check the summary calculation about ACI, BA, and CP4 Eurocode 2. This sheet we write based on the 4 different codes you see here, but in ACI there are spiral column and tie column, but in BA or in the Eurocode not classify spiral or tie column. It design are the same, but in ACI it is special. It is special from the spiral and the tie column. You can check here. Here I click a type column and I include rebar for calculation, or I include the eccentricity of the cross section. You will got this answer. Okay, for the ACI code, the bearing capacity of the concrete wall pile is here, and for the BS code is here, and this one we consider only for the concrete, not include rebar. So you have to focus on this two to include the rebar. Okay, you see here the spiral column include rebar, include eccentricity, diameter of ball pile is 1 meter, concrete cover, and you see here the area of the cross section, and here is the percentage of rebar, and here is the main rebar, and main rebar strength for the stirrup or for the link or the ball pile, and for the shear strength or the link you can input the concrete strength. So we had to limit only 30 megapascal according to CP4. Okay, CP4. Now we have to select only the maximum for 30. Okay, 30 megapascal. We based on the CP4, and we will calculate the bearing capacity of our section. Okay, in generally we can design based on concrete section only, not include rebar. Okay, so in the concrete wall pile you can design it by using the concrete strength. Okay, concrete strength, allowable strength only to verify, not include rebar. But in the case I will show you both by using rebar in calculation and by ignore rebar in calculation. You see here, when we include the rebar, it is the bearing capacity of the cross section is here. But when we do not include the rebar in calculation, you see here, it is the bearing capacity of concrete wall pile. You see here the value is almost similar. Okay, for this code. Okay, and for this one we call it allowable stress. Okay, allowable stress. If you multiply with allowable stress with 1.4, you will get the similar result with the ultimate limit state. Okay, now let's start. Let's see here.